Hello everyone, welcome to the class on PLC principles and applications. A certain workbench undergoes reciprocating motion, moving from right to right, pressing the stop button and simultaneously starting left movement. From left to left, pressing the stop button and simultaneously starting right movement using ordinary forward and reverse manual switching to execute right and left movement, which is inefficient and inaccurate in positioning. This task will use PLC to achieve automatic round trip of the workbench. I/O address allocation. In order to solve the problem of inaccurate forward and reverse stop and the inability of position control to operate automatically in the reverse direction, the traditional relay contactor control method is adopted, as shown in Figure 1. In the control circuit, right limit position switch SQ1 is used to disconnect KM1 branch and stop the right line. Meanwhile, KM2 branch is connected for left line. Left limit position switch SQ2 is used to disconnect KM2 branch and stop the left line. At the same time, the KM1 branch is connected to the right and the running direction is switched reciprocally, which constitutes the automatic round-trip control of the workbench. Input: start_button_SB1 start I0.0. Start_button_SB2 start I0.1. Stop_button_SB3 stop I0.2. Position_switch_SQ1 stop I0.3. Position_switch_SQ2 stop I0.4. Position_switch_SQ3 endpoint protection I0.5. Position_switch_SQ4 endpoint protection I0.6. Output: contactor_KM1 control the motor Q0.0. KM2 contactor_KM2 control the motor Q0.1. Peripheral wiring. The L+M terminal is connected to a 24V DC power supply. The stop button uses normally closed contacts, while the start button and position switch use normally open contacts. Position switches can also use proximity switches. Contactless position switches and position signals can be obtained without collision. Connect the I0.0, I0.1, and I0.2 terminals to the corresponding buttons. Connect the I0.3, I0.4, I0.5, and I0.6 terminals to the corresponding position switches and connect the other end in parallel to connect the DC power supply to the 1M terminal. The contactor adopts a DC contactor with 4L+4M terminals connected to a 24V DC power supply. Q0.0 connected to KM1 coil and then connected to the negative pole of the power supply, and Q0.1 connected to KM2 coil and then connected to the negative pole of the power supply. Design program. Both forward and reverse rotation operate continuously. First, design two program segments that start and stop to achieve continuous operation in one direction. The two output coils of the forward and reverse directions cannot be connected. Simultaneous LAN interlock protection is provided through the normally closed contacts of the output relay. Connect the SQ1 normally closed contact in series to the Q0.0 coil branch. Disconnect the Q0.0 coil and connect the SQ1 normally open contact in parallel to SB2. Connect the Q0.1 coil and achieve automatic switching from forward to reverse when reaching SQ1. Connect the SQ2 normally closed contact in series to the Q0.1 coil branch. Disconnect the Q0.1 coil and connect the SQ2 normally open contact in parallel to SB1. Connect the Q0.0 coil and achieve automatic switching from reverse to forward rotation when reaching SQ2. Series SQ3 normally closed contact. Automatically cut off Q0.0 coil branch through SQ3 normally closed contact. The SQ4 normally closed contact in series automatically cuts off the Q0.1 coil branch through the SQ4 normally closed contact, achieving terminal protection. 4. Program input. Hardware configuration is carried out first. Open TIA Portal Software, switch to Project View. Create a new project, project name, Automatic Round Trip. In the project tree, select Add New Device. Click Controllers Somatic S7-1200 and select CPU 1215 DC/DC/DC, Article No and Version. Article No and Version. Click on Profinet Interface _1, click on Add New Subnet, set IP address in the project. Click Add New Subnet and set IP address in the project. Open PLC tags and click Add New Tag Table. Start _ button _ SB1, data type bool, address I0.0. Start _ button _ SB1, date type bool, address I0.0. Start _ button _ SB2, data type bool, address I0.1. Start _ button _ SB2, date type bool, address I0.1. Stop _ button _ SB3, data type bool, address I0.2. Stop _ button _ SB3, date type bool, address I0.2. Position _ switch _ SQ1, data type bool, address I0.3. Position _ switch _ SQ1, date type bool, address I0.3. Position _ switch _ SQ2, data type bool, address I0.4. Position _ switch _ SQ2, date type bool, address I0.4. Position _ switch _ SQ3, data type bool, address I0.5. Position _ switch _ SQ3, date type bool, address I0.5. Position _ switch _ SQ4, data type bool, address I0.6. Position _ switch _ SQ4, date type bool, address I0.6. Contactor _ KM1, data type bool, address Q0.0. Contactor _ KM1, date type bool, address Q0.0. Contactor _ KM2, date type bool, address Q0.1. Contactor _ KM2, date type bool, address Q0.1. Input the program and click Program Blocks to open the main OB1 program editing page. Design two self-locking program branches through normally open contacts and output coils, and set the corresponding addresses. Realize interlock protection by output relay normally closed contact. Connect the SQ1 normally closed contact in series to the Q0.0 coil branch, and connect the SQ1 normally open contact in parallel to SB2. Connect SQ2 normally closed contact in series to Q0.1 coil branch, and connect SQ2 normally open contact in parallel to SB1. Connect the normally closed contacts of SQ3 and SQ4 in series on the branch circuit for terminal protection. After writing the program, click Compile to view the compilation information and modify it in time until there is no error. 5. Program Simulation Verification. Click on the Start Emulation button to load the program, start the module, and turn on the program monitor. The green contact indicates on and the blue dotted line indicates off. Open the Factory I/O Simulation software and click on Start Simulation. The control cabinet door is equipped with start and stop buttons, and the workbench is equipped with position switches for left limit, right limit, and terminal protection. When Start _ button _ SB1 is pressed, Q0.0 is turned on, right line SQ1 signal is detected, SQ1 normally closed contact is disconnected, Q0.0 is disconnected, SQ1 normally open contact is closed, Q0.1 is turned on, left line. SQ2 signal is detected, SQ2 normally closed contact is disconnected, Q0.1 is disconnected, SQ2 normally open contact is closed, Q0.0 is turned on, right line. Press Stop _ button _ SB3 when stopping. Program Input. Program Simulation Verification. Finally, let's take some exercise. The above content is the study of PLC control for automatic round trip of the workbench, focusing on I/O address allocation, PLC peripheral wiring, program design, program input, and program simulation verification. Thank you all.